More than 9 decades of serving the nation. Central Board of Irrigation and Power.
What I want to say, when you go for fault current calculations, these are the minimum information you should have. You should have. Now, cable impedance, from where you will get? You know the size of the cable. You know the length of the cable. So, cable manual, manufacturer's manual, will tell you how much is the impedance. So, from there, you get it. Source MVA. Source MVA, you cannot get across the table just like that. It is being fed from somewhere. So, from where it is being fed, from that utility, you have to collect the NEA level. When I go to the final thing, how to calculate also source NEA, that also I will tell you, so that you yourself have to verify, you yourself can calculate how to calculate the source NEA. That I will tell you, but time should permit me. Sir, it is not a very difficult thing, nothing electrical. It is purely physics. If you try to put your eyes on the things and ears and then combination of the brain, you will understand it. It is basically physics, because civil engineer is also aware of the basic physics. V by I also everybody knows. It is a AC circuit, so that's why it is coming in the impedance. So, then transformer percentage impedance you must have. So, one thing you must keep in mind, transformer percentage impedance, when you go for commissioning, you check from the nameplate details, because nameplate is engraved, this percentage impedance is engraved after testing, manufacturing and testing it is. So you will get the actual figure. So if you want to have the methodical way, if you want to do the calculation, the relay setting calculation, for that you need a current. So you can use that impedance value, percentage impedance value. Now you see, here in this particular case, you have got everything in ohmic value. Everything in ohmic value. Everything in ohmic value. Then how to calculate? How to calculate? Either you go to ohmic value or you go to percentage impedance. It is your choice. How do you go? Now, cables, I am having ohmic value, so I am choosing to go to ohmic value only. Now you see, the source, this is 11 kV by 250 MV. So, this will have a source impedance. That source impedance, suppose ZS. How much will be the ZS? What we have read in engineering college? Impedance is equal to kV square by MVA. kV square by MVA. You can verify it dimensionally also. I am putting first kV square by MVA. Whether you are correct or not, how to verify it? For every step you have to have a verification process. kV square means denominator is MVA. MVA means kV into K, kilo ampere. So kV gone, then kV by VI, kV by K means impedance in ohmic value. Am I clear to you or not? Because you have forgotten so many things over the process. So how to verify it? kV square by MVA. kV square by MVA. kV is how much? 11 square divided by 250. How much it comes? Can you calculate? Can anybody calculate with the kV square by MVA? So kV by K, you will get figure in ohms. Am I clear?
0.48.
0, huh? Yeah? What, how much?
0.484.
0 point?
484.
4. 0.484. Value is in ohms. Okay. Now this fellow, transformer. Transformer, 7%. It is in percentage. You have to have it in ohms. What is the formula? What you have read? Percentage impedance. Percentage K is equal to Z in ohm into. No, I will not go that way. I will not. Right now, I will not go that way. ZT transform is equal to 7%. 7% means 0.07. Okay. Into how much? K square by MBA. Okay. ZT. You see, 7%. Of what? Of the ohmic value. How you are getting ohmic value? K square by MBA, the same way. Okay. How much it is? 0.07 into, it is 11 kV. Acha, yes, I have forgotten one thing. I have considered here 11, here also again, not I am 3.3, not I am going to 3.3. So, you have to choose a base MVA. Okay, my base MVA is 11. Okay. Let base kV is equal to 11 kV. Base voltage 11 kV. It is a line to line. 11 kV voltage is line to line voltage. How much it is? Into 11 square by MVA is how much? 4. Then how much it comes? How much it comes? How much it comes?
2.12.
2.12. Unit?
No.
Oh. Now everything is in ohms. This is in ohms, this is in ohms, this is in ohms, this is in ohms. So everything is in ohms. Now you don't have any problem. Base MVA actually is voltage. So current is very easy. Household current is equal to how much? Household current is equal to voltage. What should be the voltage? What should be the voltage? Huh? No, because all the ohmic values are phase. So you should have a phase voltage.
11.
Huh?
11.
11 by root 3. So you should get 11 by root 3 into 1000, 10 to the power 3, divided by GNS 0.484 plus 0.25 plus 0.05 plus 2.12. How much it comes? Can anybody calculate with a calculator? My file is something different, so are you able to recognize, understand? Huh? Yes, sir.
2186.93.
2186.93. I am putting 2187 amps. Okay.
Else.
Ampere.
Amps, I am putting the amps. Okay. Am I clear to you or not? You understand? Huh? Nothing. Everything is very clear. It is physics, nothing. V by I. You tell me, I should switch to the next. Before I go, you should be amply clear.
This is fault correct.
There are fault. First fault current. If you can calculate fault current, then setting one after the other you can do. That I will come last. Different process I will show you how to calculate the current. This is a very common configuration in distribution network. Okay, so if you address the fault current like this for any distribution network, current you calculate and set the relay yourself. There will be no chance of any cascading. There will be no chance of any unwarranted tripping will never happen. It is a purely a distribution. Now I will remove this source. The source, 11 kV source I will remove. I will connect a transmission network into it. Downstream will remain like this and transmission network are there. Am I clear? I am going into that. Have you understood this thing? Your body language does not speak that yes, you have understood it.
You understood.
Okay, na pura. Now I am attaching a transmission network in this distribution system. Okay. So I am deleting it. Now I am considering a source, a larger source at transmission level. Voltage is 130 kV suppose. This will have an NEA also, source NEA also. I am considering it suppose 1500 MVA. Okay.
This is the requirement as per the different tests. Material is same. This is our core loss apparatus. So we are checking the core loss parameters. Initially we have tested this sample and already readings are available with us, and we have now to find out that how much core loss is available in the sample. This is for the staking factor. This apparatus is for the staking factor. This is for the dimensional check. This is the dimensional check. We put up the strip on that and check the dimensions. This is for the bend test of the core. This apparatus is for the bend test of the core. उसको बेंड करके देखते हैं कितना मिनिमम आपका ब्रेक कितने बेंड स्पिन करते हैं. And next one is the SIR. That is the surface insulation resistive. This apparatus is for the surface insulation resistive. ये भी आपको एक सैंपल हमने करके दिखाते हैं कि किस तरह से लगता है. And with the previous data that we have put up here.
That sample is 425 milligrams, density 7650 per CR geometry, length 499.95 mm, width 499.91, thickness which we are observing 4 micrometer is 0.28. Right, number 1 is SST, and this is a type
Single sheet tester basically that is the question. And cross section is that automatically the software is calculated.
We are measuring the losses at 1.5 Tesla, 1.7 Tesla. Now we also observe the magnetization, polarization at 800 micrometer. Right? That is the first density. 1.5 and 1.7 is the magnetic flux density.
This is the requirement as per the standard that is to be tested at 1.5 less than 1.7 Tesla. Initially the sample is demagnetizing. This is the magnetic field generator. So pH curve that gives the losses. Here you see that it is demagnetizing now. These are the value of losses. 0.8 W at 1.7 Tesla and 1.5 Tesla is 0.57. And polarization is 1.8925. This is the material testing related to CRDA. So we have the angle repeated lab, and that is North India's only angle repeated lab. Next lab.
This is for CRGO.
For CRDA, this is the core loss measurement. That is for sticking factor. That is for dimensional checker. And this is for SI, surface insulation resistance. So these tests we carry out. That is for the smart meters 13779 and 14697. All acceptance tests as per that standards, including the magnet and temper condition that we can carry out here. That witness is going on by the REC, Rule Rectification Corporation, and that single phase meter they have installed here, and total test they are missing. Already the testing is going on. So utilities send the samples for the acceptance of the knot, as well as the samples. So all the northern utilities that are coming here for the witness as well as the sample testing. This is the reliability to them. This is our master standard. Already this is the single phase tamper condition segregator. These are all magnets. When we have to carry out the magnet test, then we can use. Then actually and idea is that side. So all acceptance plus tamper conditions plus magnet test that we can do. We can calibrate the voltmeter, ammeter, potentiometer, then energy meter also we can calibrate from this device. These two devices are for, again different meters are there. Time, frequency you can carry out with the different devices. This is the calibration lab.
How frequently you calibrate your
So it is the frequency is once a year.
Okay.
And we have to maintain that frequency. And during that frequency interval, we have to carry out the in-service checks whether the equipment is working properly or not. That also we have to see. Of the CTs and PTs, and we can carry out the testing up to 33 kV. So resistance checks we can HV higher resistance and ratio angle and phase angle. These tests we have facility for us. These are all set up equipment for us.
So for above 33 kV you have different land.
No, that is at Vadodara. That facility is only here. For acceptance testing, not PD also is not there. Only the few tests we can carry out. So this is the utility requirement. So we have the facility for the utilities. They send the samples for acceptance test and we carry out the test and then later report to us. National profile project that our equipment are under installation. And another facility that we are creating is the IS3P, that is for the new transformer oil. Right now I have the facility related to the used transformer oil, and now we are creating the facility for the new transformer oil, including the ester oil. That ester oil includes the electro as well as CBIP. All the testing is under installation for this. And then this is for the PMA analysis. This setup is for the PMA analysis. And this is for the deflection of the oil. We can measure this one. And this is for the corrosive sulfur. This is the aging oven for the CRGO samples. This is for general oven for the glassware and other things. This is the special bottles for the collection of oil samples. DGA bottles for the DGA testing of the transformers. These samples are coming to us, and sometimes the customer is sending the samples in the syringe also. like this lockable syringes. And these are all the bottle. This is the amber color glass bottle for the routine parameter checking. So this is the sample preparation area. Remaining instruments are under calibration and that has been sent. You have seen yesterday or before day before yesterday the vehicle is there. And the DGA facility that is already working. This is the dissolved gas analysis of the transformer oil. It is similar to the human blood testing. So right now we draw the blood sample from the human being and test the routine parameters and chemical properties. Similarly, we are doing for the electrical equipment. We are drawing the oil samples and we are finding out the which gases are coming. Hydrocarbons, mainly 6 hydrocarbons and 3 oxygen, nitrogen and hydrogen. And remaining are the hydrocarbon gases. Total 9 gases we are reporting. On the basis of the gas concentration, we can identify the fault, whatever the fault that is coming in the transformer. And the other tests that we have the facility is the BDV, temperature, resistivity, water intake, IFT, interfacial tension, flash point, sludge, sedimented sludge, then neutralization value. Then furanic compound is basically, if you see over a period of time, what happens is the insulation of the material becomes weak. That is the paper insulation we are having on the press board mica that is inside the construction material which is used in the transformers. It gets dissolved in the transformer. So we can find out that dissolved content and on the basis of strength of windings insulation that can be predicted. These are the facilities.
What volume of oil is required in this?
For DGA test, roughly we require 250 ml. If you see the complete parameters that I have the facility is for 11 tests at present. And for that we require 2.5 to 3 liters.
And how long will it take to analyze the gas in this work?
This 45 initial first run of the sample is the CRM standard. That is the certified reference material. Whether the known concentration that is coming or not, first we verify that one. That is for the calibration of the equipment. Another is the 45 minutes per sample. So we have prepared, you see that roughly 32 I think samples are prepared. 32 samples are prepared in a single week. So that will last. Yesterday we have started at around 11 and today it is completed. It is continuously running. 45 to 50 minutes for one DGA sample gas run. These are all carrier gases that are coming.
ये जो ऑनलाइन डीजीएस होता है जो इंस्टॉल ट्रांसफॉर्मर इंस्टॉल होता है साइट पे ही तो मतलब उनका फैसिलिटी भी यही होता है ऐसे टाइप का होता है या
नहीं आप देखिए आप ट्रांसफार्मर ऑयल वो एक सिंपली आप क्या कर रहे हैं कि कौन सा गैस कंसंट्रेशन मेरे पास आ रहा है वो एक आइडेंटिफिकेशन के लिए आपके पास हो गया अब आपकी लोडिंग कंडीशंस के ऊपर बॉन्ड्स आपके मेक एंड ब्रेक कर रहे हैं दैट मींस कंसंट्रेशन इज रेगुलरली चेंजिंग तो ड्यू टू द लोडिंग कंडीशंस कि उस पर लोड कितना चल रहा है एनवायरमेंटल कंडीशंस क्या है तो आपके जो हाइड्रोकार्बन बॉन्ड्स हैं वो कॉन्टिन्यूसली मेक एंड ब्रेक कर रहे हैं दैट विल नॉट गिव यू द प्रॉपर रिजल्ट्स वो सिंपली इसलिए लगा दिया जाता है कि आपको पता चलता रहे कि कौन सी कंडीशन मेरे पास अराइज होने वाली है बट अल्टीमेटली यू हैव टू सेंड द सैंपल टू द लैब देयर इज डिफरेंस इन दैट जो ऑनलाइन डीजीए है आपका वो नेचुरली जो गैसेस लिबरेट हो रही हैं उसको आइडेंटिफाई करता है बट हम लोग जो लैब के अंदर करते हैं दैट इज द डिसॉल्व गैस एनालिसिस कि ऑयल के अंदर जो डिसॉल्व है गैसेस उसको एक्सेप्ट करते हैं तो दैट इज द प्रॉपर डायग्नोस्टिक मेथड एज कंपेयर टू द ऑनलाइन वो आपको सिंपली एक मेंटेनेंस पॉइंट ऑफ व्यू से कौन कौन सा गैस कंसंट्रेशन पर उससे मतलब ये नहीं है कि कभी फॉल्ट आ गया उससे वो सिर्फ आपको एक प्रिवेंटिव चेक के लिए जैसे या सेल्स पॉइंट ऑफ व्यू से कई बारी वेंडर पे बोला कि ये लगवा लीजिए तो वो पर्पस ज़्यादा है बट वो मेथड जो है आपका ऑयल से एक्सट्रैक्ट नहीं करता है गैसेस वो नेचुरल जो लिबरेट हो रही है अंदर ड्यू टू लोडिंग कंडीशन और वट एवर द बॉन्ड्स मेकिंग इन द ऑयल मेक ब्रेक ऑफ बॉन्ड्स हो रहा है एनवायरमेंटल कंडीशन से वो गैसेस को वो डिटेक्ट कर रहे हैं हम लोग ऑयल से डिजॉल्व जो अंदर गैसेस है उसको एक्सट्रैक्ट कर रहे हैं This is the main difference in that online and dissolved gas analysis. Another facility we have is that site facility for transformer testing, power transformer testing. We can test 100 MVA transformers up to 220 kV class, and that facility is available to me. And but we will go to the manufacturer works. We have sample अभी लिफ्ट करेगा तो we go to the manufacture works, booster supply system is there, measuring system is ours. हम अपने CTPTs and all measuring instrument लेके जा रहे हैं, manufacture works पे वो टेस्ट करके उसका रिपोर्ट इशू करते हैं. Another facility that we have here is the energy audit studies we are doing. There is power quality studies also we are doing. Then another test that we have the facility is the MCSA. That is the motor current signature analysis. In layman language, it is the ECG of the motor. It is similar to ECG of the human being. उसमें भी कुछ इस तरह के कर्व्स आते हैं, frequency dependent है. That analysis is important. तो उसमें भी पता चल जाता है bearings डैमेज है, एंड शाफ्ट में प्रॉब्लम है, आपका रोटर अलाइनमेंट में दिक्कत है, तो वो उस टेस्ट से पता चल जाता है. सिमिलर इज द टेस्ट फॉर ट्रांसफार्मर इज SFRI, स्वीप फ्रीक्वेंसी रिस्पॉन्स एनालिसिस. Again, it is the ECG of the transformer. At first test is to be carried out at the manufacturer's work. Then second test is to be carried out at the site. We see the pattern of both the graphs. अगर वो दोनों सिमिलर हैं, ट्रांसपोर्टेशन में कोई वाइंडिंग्स का डिसअलाइनमेंट तो नहीं हुआ, that is the main purpose of that test. This is ECG of the transformer. तो एक मैन्युफैक्चर के वर्क्स पे हो गया. सेकेंड टेस्ट जब आपका ट्रांसफार्मर साइड पे बे पे रखा गया तब किया जाता है कि दोनों ग्राफ्स में क्या पैटर्न डिस्टॉर्शन तो नहीं हो, कुछ ड्यूरिंग द ट्रांसपोर्टेशन उसको वेरीफाई करने के लिए. देन अनदर साइट टेस्टिंग फैसिलिटी दैट वी हैव इज द कैपेसिटेंस एंड बैंडविड्थ ऑफ मेजरमेंट्स और मशीन एज वेल एज दैट. दीस आर ऑल प्री कमिशनिंग एंड पोस्ट कमिशनिंग टेस्ट. दिस इज द फैसिलिटी.
कौन सा गैस ज़्यादा
बट दैट इज नॉट द appropriate method. It is only giving the जो गैसेस ऑटोमेटिकली बन रहे हैं उसके 101 रीजन हो सकते हैं. जरूरी नहीं है कि वो फॉल्ट कंडीशन में गैस है. तो फॉल्ट कंडीशन की जो गैसेस रहेंगी वो ऑयल के अंदर डिसॉल्व रहते हैं, वो हम यहाँ पे एक्सट्रैक्ट करते हैं. उसका सेटअप इंस्ट्रूमेंटेशन डिफरेंट है. ये हमारा हेड स्पेस है. दिस इज द हेड स्पेस इक्विपमेंट. दिस इज द एनालिसिस इक्विपमेंट. तो हेड स्पेस इक्विपमेंट के अंदर ये हमने जो सैंपल बॉटल्स प्रिपेयर करके रखी हैं, हम देखेंगे ऑयल का, ये उसमें से ऑयल को एक पर्टिकुलर टेम्परेचर पे हीट करने के बाद गैसेस को एक्सट्रैक्शन का प्रोसेस है. वहाँ पे ऐसा कुछ नहीं है. वहाँ पे तो क्या है, सिंपली आपका एक जो गैस कंसंट्रेशन आ रही है वो उसका एनालाइज है. एक्सट्रैक्शन नहीं हो रहा है. जो नेचुरली लिबरेट हो रही है गैसेस उससे
ऑयल से बाहर आ गई उन्हीं को
वो कर रहा है. दिस इज ऑलरेडी जो आपके बॉन्ड्स में ट्रैप रहती है गैसेस, उसको हम एनालिसिस कर रहे हैं. ये मेन डिफरेंस है. उससे आपको ये नहीं कह सकते हैं कि वो से एसिटिलिनाइट या इथिलीनाइट की फॉल्ट अराइज हो गया या CO2 आई, बट इसमें अगर आ रहा है तो फॉल्ट के चांसेस हैं. ये हमारा दो तरह से इस पे मेथड्स रहते हैं. वन इज द हेड स्पेस मेथड दैट इज गिवन इन द IC. अनदर वन इज द गैस एक्सट्रैक्शन apparatus. उसमें हम लोगों को मैनुअली इंजेक्शन करना पड़ता है सैंपल का, और उसके अंदर हमारा अंडर वैक्यूम दैट सैंपल इज इंजेक्टेड, और फिर एक्सट्रैक्शन किया जाता है गैस को कलेक्ट करने के बाद सीधे से डिवाइस के अंदर इंजेक्ट किया जाता है. दिस प्रोसेस इज ऑटोमेटिक. हमें कुछ नहीं करना, हमें सिर्फ सैंपल प्रिपेयर करके रख देना. यहाँ से वो बॉटल अपने आप लिफ्ट करेगा, शेक करेगा. शेक करने के बाद उसको एक पर्टिकुलर टेम्परेचर पे जो रिक्वायरमेंट है स्टैंडर्ड का हीट करेगा. जो गैसेज लिबरेट होंगी वो इस कंपार्टमेंट में आ जाएंगी. इस कंपार्टमेंट के अलग अलग कॉलम्स हैं, डिटेक्टिंग कॉलम्स. उसमें कौन कौन सी गैसेज आ रही हैं वो उस गैसेज से द टेम्परेचर वो सीधा ग्राफ हमारा वहाँ पे आ जाएगा. ऑल इस तरह के सिस्टम है. तो इसमें हमें सिंपली सैंपल रखने तक ऑपरेटर का रोल है, उसके बाद मैनिपुलेशन में ऑपरेटर का रोल नहीं है.
So what we felt that we knew so many things and we were lagging so many things there was some gap. So this training helped us to bridge those gap and get a knowledge, the concept behind the thing. We got our concept clear, and the best part was that we were always focusing on the primary side only. We were very lagging on the secondary side, which 2 days session, especially the 2 days session was very fruitful.
Yes.
That because we were absolutely neglecting this part, and now at least we are in a position that when we go back, then I don't know we can do or not, but at least the contractor cannot trick us. So that is something that we are confident that now contractor cannot trick us. we can at least know what is going on there. Earlier that was lagging with us, and moreover there are that I think Mr. Arora, Ramnik Arora. So his session was also very good. We found very much, now we are confident with the design of earthing and how to deal with the contractor, especially what data should we give and what should be taken from the contractor. So actually we are dealing with the contract only. So those parts were very fruitful with him. So I think overall our objective is fulfilled. Thank you.
Well, I had a very vibrant interaction with all the participants individually. And I have tried to understand what are the gaps. I tried to bridge them. Now he is telling that, Mr. Rupesh is telling that bridges have been made. Now it is not only potholes, all are connected. It delighted me. Then he said another thing, that secondary side. Secondary side, I believe I am the faculty member who contributed in the secondary business. So if I could fulfill their requirement from secondary side, then I feel that I could do something for the benefit of this power engineers of Nepal. My submission to these delegates will be that they should dissipate whatever knowledge they have gained from here to the downstream. Not only with the contractor, to their juniors, so that they also can become a part and parcel of solid transmission system of Royal Nepal. The day I find that Nepal is able to transmit power to India without any interruption, without any blackout, that day I will be very happy to note that they have, the participants, the delegates here, have appreciated my contribution in the secondary field. Because it is mostly the secondary field which creates havoc in the power transmission system. Major disturbance, all are mostly because of secondary side problems. If those are taken care of, grid operates in a stable manner, I will like to have a share in that stable operation of the grid by imparting my experience in Power Grid Corporation of India Limited with the participants from this August country. That is my submission. If it is fulfilled, I am more than sufficient, more than happy enough. Thank you very much.
Thank you. Sir, would you like to say something?
Yeah. So this program of 7 days today comes to its completion, and thanks to all participants from the Nepal and all the faculty members, Sarkar Sahab and others who are not present, who have contributed a lot to this workshop, and we hope that you will be getting benefited from this workshop. And I think this was the first workshop.
Yes, sir. First kind of.
Yeah. And we hope in future also this session will continue, and we both jointly will help each other. In further workshops will also be, because you will go back to the Nepal and give the feedback to your people that, and apart from giving your verbal feedback, they will see you on the field that you are a different person before going and after coming back to the Nepal in the work field. So people will observe by seeing your activity, because ultimately you have gained lot of knowledge here. And as you said, Prakash have said, gaps are filled. So now you will be different person, and your way of working in the field with the staff, with the juniors, with the seniors, way of talking, way of expressing yourself will be quite different. So we hope in future also this relation will continue and enrich. Thank you very much.
Thank you, sir. Thank you, sir. Mr. Admin. Mr. Rupesh Kumar sir. Mr. Ravi Kumar Chaudhary. Mr. Ritesh Jaiswal.
Thank you, sir.